Hi everyone, afternoon.
Oh, it's my end.
I'll give everyone a minute just to join after the roundtables and lunch. Okay, I think we'll make a start. So hello and welcome everyone. I'll start with a really quick introduction. So my name is Amelia James and I work in the Academic Health Science Network across Kent, Surrey and Sussex and Oxford. I'm their sustainability lead. So my role is split in twofold. So on the one hand, I work with all our integrated care boards and trust and support them with their green plans. And the other half of my role is working with innovators and helping educate them on what net zero in the NHS means. Today, I'm facilitating the innovator session on consumables, which I actually think is one of the most exciting spaces. And it can cover everything from PPE and medical equipment to food and IT and signage. And we've got some amazing innovators speaking today. Please pop any questions in the Q&A function, or if you're feeling brave enough, you can raise your hand at the end. And we've given innovators around 15 minutes for their presentations and Q&A, and I'll try to make sure that we stick to times. So without further ado, I'm handing over to James, Milligan and ImageCo. And James, I can see you on the screen, which is great.
Okay, can you hear me all?
We can hear you perfectly.
Right, cool. I'm just going to share the screen with you.
Yes.
It might take a minute or two because I've got loads of pictures on it, so it's quite a big file.
Don't worry, take your time.
So bear with me.
It's always the way, isn't it, with big PowerPoints?
Yeah, so we're not far away now.
Takes a while to think about it, doesn't it?
Yeah, don't worry.
Yeah, so whilst you're waiting, we're a large format printing company based in Leeds. So we design, print and install graphics and signage all over the UK. But we have got a very sustainable approach as well with the machinery we use, the inks that we use and the materials that we use. So I think something should be coming on your screen soon.
Yes, it's just loading.
And our customers tend to be marketing companies or advertising agencies, but they're asking more and more for sustainable methods and substrates for us to use. So if you bear with me. Right, so can you see my screen now?
Yes.
Right.
Perfect.
Cool. So I'll just go through this one by one. So that's a bit of an itinerary. I'm going to go through our eco-friendly side, some of the materials we use, and then a few case studies which will highlight our use of sustainable products in the market. Just bear with me whilst I'll just time myself, sorry. Right. So our company, we've been in business since 2001. We've got 28 staff and annually we turn over £3 million. And we've got a 30,000 square foot production facility based in Leeds, but we do our thing all over the UK. Those are a list of our services. We're large formats, so we produce big things. So a lot of our stuff is signage, retail, exhibitions and events, and wall coverings. And as I say, we install most of our stuff across the country. Here are just a few examples. Some of these might not be relevant to you guys, but I'll just gloss over them. So the one on the left is a product called Consumables, where you print the graphic on the glass, but you can still see through the glass on the other side. On the right-hand side is a typical example of a large sign that we'd produce. Some more signage. The one on the left is unilluminated. The one on the right is illuminated. So this is our bread and butter type of work. Now, this is quite interesting from a sustainable point of view, architectural vinyl is a way of refreshing doors and surfaces with vinyl rather than replacing the physical door. So if you look on the picture of the left, this was an office which had about 20 doors which were with a wood colour, and they wanted to change them. So rather than removing the doors and having to throw them in a skip and then get a van to turn up with a load of other doors, we can just simply turn up with a roll of vinyl, which is about 1 metre wide, and just cover the door with the vinyl by applying it to both sides. So on the right hand side is what the doors look like once we've done that. So that saves all your footfall costs of lorries and vans turning up with new doors and taking away old doors, skipping the old doors. So it's quite a sustainable way of refreshing old and tired work surfaces. This is doors, but it could be desks, tables, chairs, or any furniture really. And there's literally thousands of different finishes. That tends to be, well, that's a black vinyl we applied, but it could be anything really. So there's just a few stats about our carbon footprint and the fact that we're solar powered. Also, some of the materials we print onto, we've got an agreement with the Yorkshire Dales that we'll plant a tree for every square metre of print, but I'll go through that in more detail later on. So these are our two most eco-friendly machines. They are made out of recycled materials. They use water-based inks, and the cartridges, which would normally be plastic, which would probably just go to waste, are made out of cardboard now. So from a print point of view, they're as eco-friendly as they could be. So the three main materials we're using that are sustainable, and we weren't doing these like 3 or 4 years ago, and now we're printing these on a daily basis, is a one-piece wall canvas. Now, because we can print up to 5 meters wide, we can print an entire wall in one piece rather than in drops, so it looks fantastic. But the main selling point is it's made out of recycled bottles, so it's sustainable and a great product. And for every 10 square meters of that material that we print, we've got an agreement with the Yorkshire Dales that we will plant a tree, and we tend to do that twice a year. Number 2 is fabrics. We do a lot of light boxes, mainly for retail. Again, we now print on an eco fabric, which illuminates just as good as the old PVC version. But again, this is made out of plastic bottles. The material is made out of plastic bottles. And the third one is a material called Zedible, which is a lightweight card, which, because we've got a cardboard engineering team, can make some amazing products, almost like they were made out of wood. But I'll add some more flesh to the bone in the next few slides. So here's some examples of the eco wall canvas. The one on the left went in a school. These are just sometimes customer suppliers artwork, sometimes we create it ourselves, but these are just high-res photographs that have been supplied to us. And you can see you can make amazing spaces to what would otherwise be white walls. And the one on the right was in an office. And as you can see, we fit all that in one piece, but we can cut around plugs and doors and alarms, you know, so it looks seamless. More examples of eco wall canvas. The one on the left is actually in a hospital. We actually took that photograph of that bridge. It's somewhere in Yorkshire near where we are. And then the one on the right is just another example of one in an office. But they really make boring spaces to give them identity and personality. And this is just an example. This was in a play gym in Yorkshire Wildlife Park. So all that tree pattern went on for 100 meters in and around this like trampoline park. And we printed that in 10-meter sections and obviously joined it together. Eco fabrics. So these are similar to the wall covering I just showed you, but these illuminate. So these again are made out of plastic bottles. Again, 2 years ago, this would have been all laden with PVC and plastics. The one on the left is actually our reception. So that's mounted to the wall is the light box, and then just the soft fabric clips in. The one on the right, same principle, except it's freestanding, so it's got some feet. So we tend to use them for exhibitions and events, which we do a lot of. Some other examples, exactly the same, but these aren't illuminated. The one on the right, I don't know if you can see, we can, because of our print technology, we can make bits illuminate. So for instance, on that one, only the white text and the logos illuminate. Everything else stays a dead colour, or a flat colour, should I say. So then Zenita. So Zenita is card, which is 16 mil thick, and it comes on like 3 meter by 2 meter sheets. So we print direct to it, and then we cardboard engineer it into stands and shapes and tables. So the one on the left is pretty straightforward because it just all clips together using like feet and stuff like that. But the one on the right,
Are you in this room?
the one on the right, that table, that plinth, and the whole wall is all engineered out of Zenita. So it's almost like it's been made out of wood, but it isn't. It's made out of a recycled card. And before we would have made exhibition stands using metal, wood, acrylic. Now we make the majority of them out of this recycled card, which can provide structure. Now, this is one of the best stands we did out of this material. It was a 10 meter square, like greenhouse in essence. So as you can see, there's cross beams, there's a roof, it's strong enough to support tellies. And again, it looks like it's wood covered in graphics, but it isn't. It's literally cardboard. We've printed onto it. We've then CNC'd it, and then we could fold it and make it into shapes which are strong enough to withhold TVs and lighting, and that had dozens of people walking around it. And then that stand was reused 3 or 4 times, so it's sustainable in that effect as well. So this is a product we've launched for exhibitions to be sustainable and help keep costs down. So the picture on the left, we build the structure out of cardboard, the same stuff. It's this stuff called Zenita, which I keep on going on about. And then if you look on the right, it's then covered in graphics. So all we do then is just using magnets, we clip graphics onto the front of it. So it means if you're exhibiting a lot, you can keep the same structure behind it, but so all you've got to do is refresh the front. And then that's that same stand, but it's just to show it all collapses down into that little box. Well, not a little box, a box on the right hand side, which again, that's made out of cardboard. And that just shows how easy it is to transport. So it means when we're on site, rather than lugging big sheets of metal or wood or acrylic or what we used to do, it all packs down into a lightweight box. So it means there's less transport and less people on site to assemble these things together. So this is a case study. So this is a client of ours who we branded their offices. They've got 25 across the UK. So we did lots of other signage, which probably might not be relevant to you guys, but each site had 3 or 4 wallpapers. They call them feature wallpapers, and some of them had like quotes on and inspirational sayings and stuff like that. But once we'd completed the project, which we finished probably in early summer this year, in total, just short of 2,800 plastic bottles had been used to make the material that we printed onto, which would have otherwise probably gone to landfill. And also, because of the amount of square meters we printed, it resulted in them as a company going to the Yorkshire Dales and planting 63 trees. So that was quite a nice project. This is a job we did at the LGI, which is the nearest hospital to us. And basically we used the latex machine, which is the machine that uses water-based inks and is made out of recycled material. So we produced vinyl cutouts over about 200 meters of corridors in the children's ward. So otherwise white walls were given a bit of fun, just something to look at and enjoy rather than just plain white walls, because there's a lot of kids who spend a lot of time there. And that was a job we did a couple of years ago. This is a job we do for a client who make murals in receptions for hospitals all over the UK. Not ultra sustainable, to be honest, but I just thought I'd include it because it might be relevant to some of you. And then finally, I think it's finally, this is our sustainability report is on this link here, which I can send to you after the presentation or after the meeting. And I think that's it. So that's it for me.
Thank you so much, James. I found that so interesting. The vinyl covered doors, it feels like it completely refreshes the look, but I'm guessing for a fraction of the cost, and so much better for the environment. The wall covers, the photos. Actually, I don't know if anyone on this call were just in the round table, but we were discussing how do we connect hospitals to nature and kind of bring in trees, that kind of green element in. So I loved the idea of having beautiful scenery on the walls. Does anybody have any questions? Our second innovator isn't able to join, so we've got a bit more time. Does anybody have any questions that they'd like to ask James? I've got a question for you, James, if nobody
Go on then.
wants to jump in. I wanted to ask about climate leadership in ImageCo, because it feels that your senior leaders are really bought into kind of the sustainability element. Has that been a journey for your business, or was sustainability kind of built into the business from the onset?
No, so we've been in business 20 years. It's only really the last 3 or 4 years we've gone down this road, and it's mainly directed by one of the directors.
Okay.
So the first thing was getting the eco-friendly machines that use water-based
Yeah.
inks, and then the second thing was sourcing sustainable materials rather than traditional print materials.
Yeah.
The reason why I only showcased 3 were because those are by far the 3 most popular.
Okay.
To be honest, some of the other ones just don't perform as well as the normal ones. So we only highlighted the 3 which I did because I know they work and are just as good as the old traditional methods. And then the solar power, we got that installed just after lockdown. And it's just snowballing really, because our customers are demanding it now.
Yeah, no, and that's brilliant. That's amazing. Have you noticed, because this is something that was discussed as well, a difference in cost when you're looking at sustainable materials? Have you felt that you've had to increase your cost, or?
I would say they're just on a par with what we used to charge. Obviously, costs have gone up across the board, but the cost of these materials hasn't gone up any more than like plastics and metals we used to use before.
Okay, brilliant. Oh, well, thank you so much, James, for joining. I felt like I learned so much then. Does anybody else have any other questions for James? No? Okay, we will move on to the next innovator if Rob Knight is here. I think I did see him join at the beginning, but otherwise I will give everyone a couple of minutes break. Oh, he's joining now. Hi, Rob.
Hi.
Are you happy to go a bit earlier?
Absolutely. Does anyone need a quick break, or?
Yeah, if anybody wants to raise their hand, if anyone wants 5 or 10 minutes, I'm happy to start at 1:30. But I thought if the innovators are here, we'll continue. Okay, let's carry on. Rob, over to you.
Okay, just share. Right, can you see that?
We can.
Yeah.
Thanks, Rob.
Right. Okay, so today I'm going to talk about mobile first, which is the art of the possible today. And fundamentally, as I'll go on to, this is around using smartphones much more effectively and reducing the numbers of end user devices within your organization. So a little bit about us. We were formed in 2010. We're specialists in all aspects of end user device, remote access, and the associated technologies. We offer a range of products to complement those end user devices as well. We've introduced some managed services, including some healthcare products, which focus on social care, loneliness, isolation, and travel reduction. We've worked for a wide range of customers, including the Ministry of Defence, Department for Education, the Foreign and Commonwealth Development Office, this services arm, the Insolvency Service, some police forces and financial services organisations. So quite a broad range of organisations, either within public sector or regulated business. My website is there. There'll be more information. Yeah, there'll be a link to that at the end of the slides as well. So what is mobile first? So mobile first is the use of smartphones as a primary end user device for consuming or creating content and for other computing tasks. You might also hear terms such as one device used as well. And why can we do this? Well, smartphones are extremely powerful now. Modern smartphones have processors that are as powerful as the processors that you find in laptops of 1 or 2 years ago. So very, very powerful devices. And here's a slide showing a traditional sort of benchmark. And as you can see, the Intel Core i5 is slightly slower than the Snapdragon, which is found in many of the more modern sort of higher specification smartphones. If we look at end user IT carbon emissions, they actually, for desktops, laptops and tablets, account for 1% of global greenhouse gases. And that works out around about circa 370 million metric tons of CO2 in 2022, and not far from the total amount that the UK produced, which was 417 million tons. And the primary drivers for that are the manufacturing of 400 to 460 million devices every year, and the consumption of content that drives electricity usage by 4.2 billion end users. Overall, information technology accounts for about 4% of global greenhouse gas emissions. But we could actually reduce the amount of end user device emissions by 40 to 60%. By reducing the numbers of end user devices per person and extending their life. Typically, lives can be 2 or 3 years, but actually there's no reason why they couldn't be used for 4 or 5 years. Some of the upcoming challenges that we're seeing within the industry: Windows 10 end of life. So that's coming in October 2025. And currently 43% of Windows computers don't support Windows 11. And so for an organisation like the NHS, which has between 1.1 and 1.2 million Windows devices, that's 500,000 devices, over 500,000 devices having to be replaced in the next 2 years, or repurposed so they can be used for longer, but using something other than Windows. Obviously, some of the other challenges are spiralling energy costs. Even though prices have come down slightly, they're still very, very high compared to 2018, 2019, and Windows PCs use a lot of energy, and I'll come on to show some examples of that in a minute. Lots of organisations now have much more aggressive net zero targets, as do the countries in which they reside. And generally they're being required to be more environmentally responsible by their end users, their customers, and they have to report on their emissions as well. And another driver is costs. Overall costs, more pressure. Costs are increasing. There's more pressure to do more with the same amount of money that you have. So if we look at some details about computers' energy use, emissions versus smartphones. So if we look at a traditional desktop computer, that can use up to 2 kilowatts of energy per day if that's running 24/7, being used on and off throughout the day. And that equates to around about 170 kilograms of carbon dioxide every year, and 226 pounds in electricity. And that's just using the 0.31 pounds per kilowatt hour at the moment. So in 5 years, 20,000 desktops left on 24/7 would generate up to 17 million kilograms of carbon dioxide, and actually cost 22.5 million pounds in electricity. If you look at the NHS, which has around 1.2 million Windows computers, if 1 million are desktops, and they're the most energy consuming devices, over 5 years, those 1 million devices could be consuming over 3.6 billion kilowatt hours of electricity, generating 850,000 tons of CO2, and costing 1.1 billion pounds in electricity. Now, if you look at a smartphone desktop, which uses only 0.34 kilowatt hours per day, you could save 3.3 billion kilowatt hours of electricity, 706,000 tons of CO2, and 939 million pounds in electricity costs. So potentially some significant savings, as well as reductions in carbon output. And just to put that into perspective, that 850,000 tons of CO2 would require 8.3 million trees to absorb that amount of CO2 every year, just for the PCs in the NHS. So who's actually done this? Well, the Garda were faced with some challenges during the pandemic, where they couldn't get enough laptops, and they had to find an alternative. And actually, they ended up using smartphones. So we helped them procure some laptop chassis, which effectively is just like a display in a laptop chassis, and it has some electronics in there to allow the smartphone to connect and produce its display on that. But it has no CPU or RAM or storage or anything like that. So it's not a computer in itself. It's actually the smartphone doing the work here. and they were able to use this very effectively throughout the pandemic, and they continue to use it today. And in the office, including the back office functions, they simply supplied monitors with a USB-C connection, and they plug their smartphones into those, and they use the same method of connecting, whether they were out and about or whether they're in the back office. They just use their smartphones as their primary computer device. Thales is another organisation. Thales is a big French sort of defence and manufacture defence and all sorts of other things. So they've chosen to use Samsung terminals, and they just plug their smartphones into monitors via USB-C, and then they have their desktop operating environment there. And they use things like remote desktops. So that's where you run a Windows machine effectively on a server, and that could be in a data center, or more commonly now in a cloud data center, such as Microsoft Intra or Azure, as it used to be called, or AWS, Amazon Web Services. And ScotRail have also done the same thing. So they've equipped a lot of their people with 27-inch monitors, keyboards and mice, and they use it to connect to Windows desktops. So what are some of the benefits of this mobile first approach? So lower cost being one. The smartphones are far less expensive. So we're looking at a few £100s for a smartphone as opposed to £600 or £700 for a desktop, or more for a laptop. Lower energy use and emissions, so they only use about 15 to 20% of the electricity that a Windows PC would use, for example, and that also includes the keyboard, monitor and mouse, because both would require keyboard, monitor and mouse. It's actually the smartphone that's actually reducing the power consumption. A lower embodied carbon as well, so just the PC base unit itself, that can generate up to 300 kilograms of carbon during manufacture, whereas a smartphone is typically 50 to 80 kilograms. Because you only have one device to support and manage throughout your business, it reduces the amount of management support resources that you need for it, and less training as well, because you're just using the same device that you would use for mobile use as you would use for your desktop computer use. It's a much more intuitive switch. You plug it in and you're presented with an interface that's very similar, and an interaction which is very similar. If we look at some examples of what a smartphone desktop might look like, so we're using a rugged Samsung device here, an Xcover 6 Pro, they're less than £400, exclusive VAT, I think they're about 370 now. They come with 5 years of security updates, so coming back to that extending the end user device lifetime to reduce those emissions from devices, so going from 3 years to 5 years. We've also got a removable / replaceable battery. That's one of the bits that normally goes on a smartphone, or it degrades to the point where it becomes less usable. So because that can be easily replaced, the back of the phone just pops off and the battery comes out. It means that device is going to last a little longer and maintain its performance throughout that period of time. So you may have come across an organisation called Fairphone. They produce the most sustainable smartphone available, which looks at not just the actual sourcing of the materials, but also the working conditions that the people producing the smartphones work under. And they also support the use of external displays. And there's two images there. The top one is one of the Samsung Xcover devices accessing a Windows remote desktop. That's using Citrix in that particular example. And Citrix is one of the products that's been deployed within the NHS together with VMware Horizon and something called Azure Virtual Desktop as well. So those were deployed or have been deployed in the past, and I think they were quite widely used during the pandemic to provide remote access. There's no reason why those couldn't be used to access services internally just using the smartphone. And some of the other benefits are you're reusing existing equipment, so the monitor, keyboard and mouse is the same. Because you're using your device that you carry around with you, you don't have to log in and log off as you do with a Windows device, so it's almost instant. You plug it in and within a second or two you've got your desktop up and running. You're good to go. You're not having to wait for somebody to log off and then for you to log on, and I've heard that can take some time in some NHS trusts. And again, coming back to the reducing the amount of infrastructure you need to support these devices, because you've got one device instead of two, You don't need the same number of licenses. You don't need the same amount of management infrastructure. You don't need the same amount of support resources to manage or provide support to those end user devices. Coming back to what I was talking about, energy, so including the 24-inch monitor, keyboard, mouse, this uses between 20 and 28 and 30 watts of power. So throughout the day, we're looking around about 0.34 kilowatt hours of use. And again, that changes because whereas with a desktop PC, it's constantly on, albeit sort of fully working and perhaps in a less sort of active mode, it is still switched on. Whereas with a smartphone, once you undock it, you're using a couple of watts of power at most on the smartphone, and the keyboard, monitor, and mouse go into standby. So very, very low power consumption there, and that's what really drives that reduction in power consumption. And if we look at use of a smartphone within healthcare, so in a mobile scenario, you've got things like electronic observations, triage. You can access and update patient records on the move, but that's inpatients at the bedside, etc. You can use it for barcode scanning of prescriptions or drug movements or allocation, etc. And there's another capability on some of these devices where they've got a button on the side. They can be used as a walkie-talkie. So there may be some scenarios where that push-to-talk walkie-talkie functionality would be useful as well. And once they're docked, they can then be used to access mobile applications such as Outlook, Teams, Excel, web applications, and also virtual desktops, similar to Citrix, which I showed a little bit earlier. You can also get a laptop variant as well, so we're not just looking at desktops. So this is similar to what the Garda we're using. It's basically a display in a convertible shell, so the screen does turn all the way around. And this would be perhaps more applicable to people working from home or community workers who need to access the systems when they're out and about. Similar sort of applications can be used to the desktop. And in terms of cost, the actual laptop and the smartphone is in many cases less than an equivalent laptop. And because they don't have any data or CPU or RAM, they can be shared easily because you just plug it into any compatible smartphone. So one of your colleagues could come along and use the same device. So it means they're easily shareable within an organisation or as a pool device if people need to book them in and out. So what I've shown so far is using Android devices. But what about iPhones? What can you do with those? So there is some support for iPhones. It's not as extensive as there is for Android devices. But a couple of products called VMware Horizon and Citrix do support the use of external displays. And Windows 365 and Azure Virtual Desktop is getting that shortly. For desktop use, you can just plug a small adapter box into existing monitors and use an existing keyboard. And the iPhone is actually used as a touchpad. Wireless desktops, again, wireless may not be as usable within your environments, but it might be something that could be used at home, for example, for a remote working scenario. You can use a Bluetooth keyboard, a wireless display, and again, the iPhone can be used as a touchpad. And then there's a laptop, it just connects via a cable. So similar to what you saw with the Android smartphone I showed a little bit earlier. How about augmented reality or glasses, those sorts of things? Well, that's possible too. So it is possible to actually have this information being displayed, these desktops being displayed in a set of glasses. So DeX is the Samsung solution, but there are others available, such as Ready 4 from Motorola, X-Space from CrossCall, that's been recently introduced. So you can plug a smartphone into a set of glasses. You can access your mobile applications, so similar to what you had on the desktop or what you had on those laptops. But here, you're using your keyboard and mouse to navigate, but you're actually viewing the desktop through a set of glasses. Again, you can access Windows through the products as Windows 365 or Azure Virtual Desktop. Windows 365 is shown there. And for training, you could stream training information to the smartphone. That would be displayed on the augmented reality glasses, and then you could use Bluetooth peripherals for any further interaction with the training. And that's about it. So last slide. So you know, we've got some experience of putting this out into the real world. You know, we'd be more than happy to talk about this in more detail with people if they want to try and understand the possibilities. You know, would these sorts of innovations benefit yourselves? As you can see, some of the reduction in energy use and consequent emissions is quite significant. There's also a reduction in embodied carbon. So I'd like to think this can all work towards net zero. But you may have also seen on one of the slides, and perhaps I didn't highlight it as much as I should have done, the NHS Digital have come out with some sustainable architectural principles, and that those are deliver sustainable services. And one of those is to provide access that minimises end user device numbers. And this is doing exactly that. So we are looking for innovators in the NHS to trial these sorts of technologies. And we do have some kits that can be used for 30 days free of charge. So there's no cost to yourselves to actually get the equipment and try it out. Obviously, you'll have to connect it to something, but yeah, we can certainly make the equipment available for 30 days free of charge on a trial basis. Any questions?
Oh, brilliant, Rob. Honestly, that was so interesting. I'd heard of losing the wires before, but it was just so fantastic to get all the detail. And I didn't actually know about the augmented reality either. So that was really interesting. What I would say to any NHS colleagues, if you're interested and you're looking to trial, please do reach out to Rob as well. You have got some questions in the chat. So the first is from Abe. Would you be able to quote or just verify some of the sources for the energy use and emissions? Please don't feel you have to do that now, but I think it'd be good to just kind of.
So yeah, so on the slides, we've quoted Julian Parker. So this was around the amount of the percentage of global house emissions,
Yeah.
etc. Some of the other stuff we've actually measured it ourselves. So we've actually plugged in a power meter and monitored how much energy machines are using. There is some other information out in the public domain that talks about how much energy PC can use. So you know that can be up to 200 watts an hour. So, and obviously 24/7, that's a lot of hours, but we've not assumed that those devices are in use all of the time. So we've made an estimate that they're in continuous use for say 10 to 12 hours, and then they're in a reduced power mode where they might be sort of undergoing some sort of maintenance or Windows housekeeping or whatever the rest of the time, so they consume less energy. And that's how we've arrived at that 2 kilowatt hours per day.
Okay.
On there. So we've made some assumptions.
And then no, thanks so much for that, Rob. And then we've got a question from Tim, which is the exact same question I had on my piece of paper. What is the impact on the phone batteries when you use them as the main device, Rob?
So when they're plugged in, they are actually being charged. So you're not going through a full charge discharge cycle. So when they're plugged into these, they're just being powered effectively by either the laptop dock or the desktop dock. So not only is it topping up the battery, but it's also powering the thing as well.
Has there been any, because this is just another question that's come through, any kind of research into the lifespan of the devices? Does it affect them from using them a lot?
So the original devices, so this technology was originally released by Samsung on the Samsung S8, which I think was back in 2017. That used to run a little bit warm, so the dock that they shipped with that had a fan in it to keep the device cool. Because of the advancement in processor technologies, the reduction in the size of the transistors that they use, etc. These devices now typically run no hotter than they would do using traditional computing tasks.
Okay, fantastic. Would you be able to pop your email in the chat, Rob? Everyone will have contacts after, but it'd be just good if any NHS colleagues want to reach out to Rob and want to look to trial that for 30 days. Are there any more questions for Rob before I move on? Okay, so now I'm handing over to, I think it's Andy. Is it Andrew, or would you prefer Andy?
Yeah, usually Andy, yeah, but our IT systems are very formal.
Okay,
Hopefully
no,
you can hear
fantastic.
me okay.
Oh, amazing. Andy, over to you.
Okay, let me just see if I can share my screen.
Fantastic, take your time.
And hopefully you can all see that.
Perfect.
Brilliant. Okay, thanks, Amelia. Well, thanks everyone. It's great to be part of this session. There's some fantastic innovations I've seen already. This is going to be a little bit different to the last couple. Very different technology, but hopefully one that can really help the drive towards net zero. We're going to talk about a technique that's quite well established in the one hand with UVC decontamination of devices, but how we can harness the latest advances in that to maybe drive more sustainable practices using this technique for reusing various things actually that are used in healthcare. So before we do that, just to introduce us, we're Mackwell Health. I'm the general manager of the business. We're part of the Mackwell group of companies, and we have a background in safety critical products and services, most notably in fire safety and also emergency lighting. So these are very different to what I'm going to talk about now, but actually when you come to think about the science behind it and some of the technical skill sets behind that, they're very applicable to infection prevention and control in healthcare and other environments. So what we've done is launch Mackwell Health as a new division within the group, and our mission really is to really innovate to try and better equip the healthcare market, you know, NHS and private and other places around the world to fight infectious outbreaks, eliminate as much as possible healthcare acquired infections, prepare for the next unknown pandemic or for infectious disease. They are the two highest risks on the government risk register released a month or so ago. But to do that without compromising sustainability or the drive towards net zero, it's often thought, I think, that sometimes they can be in conflict, you know, the drive to net zero and the need to increase safety. We think, and I think there's a growing acceptance that these can be two sides of the same coin, essentially, and that's what we want to try and do. You know, we've got our background in lighting. Actually, we've been through a revolution in lighting. You've probably done plenty of sustainable healthcare projects where you've retrofitted LED lighting to replace older inefficient light sources. Well, the LED technology that's well established there is now being applied to UV. It's running around 20 years behind the lighting revolution. But actually is coming to fruition now. And I'll be discussing how that really helps and what advantages that brings. So from a Mackwell perspective, you know, we actually see that there's an opportunity for a much more connected and joined up ecosystem of solutions around infection prevention and control. And we're innovating in a number of different areas, be it personal protection innovations in PPE, be it in the built environment to try and make spaces healthier. And the thing I'm going to talk to you about today is really around decontamination. And we have a vision here to join this all up in a connected cloud-based service that can allow IPC professionals and sustainability professionals to see that they're actually achieving their goals and their KPIs. But I'm going to focus today on the middle one of these, the hygiene and decontamination side of things. And I'll talk a little bit about UV disinfection. So I'm sure some people here will understand this and will have been using it for a while. But for those that are not familiar, this is a technology that's very, very effective and has been known for well over 100 years. UVC was first actually introduced by a Scandinavian guy called Niels Finsen back in 1903 to treat tuberculosis. And it's very well established. You shine a UVC light at an object which might contain a pathogen, and it will essentially disrupt the structure of the DNA or the RNA in that pathogen and basically render it so that it can no longer reproduce and therefore can no longer be infectious. And that's been known for well over 100 years. So what's new? Well, what's new is that essentially LED has come along and can now deliver this from a solid state digital light source. So previously you had to use fairly traditional lamp sources which contained mercury, and actually UVC was pretty much restricted to that. LED sources now are a stage of readiness where they can really be considered to do this instead. And they bring a number of advantages. First of all, they can be tuned to the wavelength, and what you can do there is actually tune the wavelength to one that is closer to the peak absorption of the DNA or the RNA of the pathogen you want to target. That means you can be more efficient. They're also very small, so you can actually direct that radiation to target it using optical materials that you really couldn't do with traditional lamps, because they were just big light sources that didn't really, you couldn't really get very effective optics for them. There's also very good light distribution data from LED sources, so you can actually model what's happening in whatever environment you're putting it into, and translate that to the dose, and then translate that to how much reduction you would achieve on target pathogens. Because they're small, you can make and this is a real big one actually, you make them smaller and more compact. Takes the cost out of the product, but also makes it portable and flexible, that you can put it in a lot more places. So you can actually now do this at point of use. And one last one is because the wavelength is slightly higher in nanometers. You see the bottom graph there shows how much more transparent objects are to UVC at this little slightly higher wavelength. And what that means is that you don't have so much shadowing, so you can get better results, particularly with certain plastics. So if you're looking at eliminating single-use plastics from healthcare, consider getting new products manufactured out of UVC transparent materials. There are some very low-cost materials, silicones, FEPs, and those kind of things that can be manufactured in those materials and make them much more effective to decontaminate and reuse. A bit of a problem.
Andy, are you okay? I think you've just got on mute, Andy.
There we go.
There we are.
There you go.
Perfect.
Had a slight glitch in Teams. Apologies.
Don't worry, happens to us all.
Okay. So you should be seeing the white box slide now. So these are the products that we've used to embody the latest UVC LED technology. You can see they're available in a range of sizes. So the smallest one is literally like a little, well, the middle one actually here is about like a little microwave oven size, and the one below that is about a quarter of that size. So these can be, placed very efficiently in different areas, very discreetly in different areas, rather than be large, capital equipment purchases that might have to go in just one single dedicated location. They basically, as you can see from the inside, contain all of the internal walls are lined with highly reflective material. So the UVC LEDs are kind of very discreetly embedded in that material. So most of what you see is just reflections. So you can put something in there and it's getting reflected UVC radiation, constantly targeting it. And then the other thing we can do is create models. So create predictive models of how different pathogens might be killed, how long they need, how much reduction you'll get by simply importing the 3D CAD files into a program, and then basically looking at how much light is going to land on their surface, and therefore how much time you need to achieve a certain level of reduction. You can also RFID tag these, so you can get a traceability of the disinfection history. I'll come on to that a little bit more detail later. Cycles can be very quick. We're talking minutes. Again, I'll come on to that later. And as I say, a range of sizes. So just a little bit more on that modeling. So here's an example of a modeling of eyewear. So this is protective eyewear, PPE. A lot of single-use eyewear was used, I think, as many of you will know, during the pandemic. And this can be we can predict this with the CAD models by lining them up inside the box here, and look at how this might get treated in depending on what the cycle time is and depending on what the intensity is that we designed the box for. So in the example here, you've got a 5-minute cycle that might be somewhere in between this graph here. You take that to 10 minutes and you're up at 5 log reduction. This is on a particular pathogen that was of interest there, but you can essentially use whatever combination of pathogens exist for that. And that gives us a very good method of designing this in, you know, at first stage with very good first time sort of results. The other great thing that's happened in the last year that's new, it's only taken 120 years to get to this point, is there's a new standard out, BS 8628. This is a standard for disinfection using UV radiation. This standardizes, so this looks at some of the hardest, most challenging pathogens, most resistant pathogens to UV. And it demands for healthcare environments that you do tests on 4 types of bacteria, 1 type of yeast, and you have to have at least a 5 log reduction minimum. And that allows you to certify the products essentially. So this we expect to become the standard for surface disinfection on any type of application that you might have. You know, so we're applying this right now to the white box. It's currently in that process as part of a trial that we're running, which I'll come to. In terms of sort of the value propositions, so first of all, that we worked with the NHS Supply Chain Innovation Sustainability team on PPE and looked at just a number of different things. Just to summarise a couple of examples here on the top right, if you were to eliminate all the single-use visors, and if you were to eliminate all the single-use FFP3 masks, respirators from NHS England, you can realise an annual total saving of 31 million, and that's NHS innovation and sustainability numbers, and that's a combination of procurement, waste, carbon, warehouse storage, and transportation savings, and that can be obviously multiplied up as you consider the more devices or more objects you want to decontaminate between use. That just multiplies up. You know, the more you add to it. Currently, if you want to reuse items, the current most common way of disinfection and sterilization is to use either a washer disinfector or a steam sterilizer. They're incredibly effective, of course. They do very good efficiency, but they are large, energy hungry devices. And they don't just use electricity, they also use water, they use natural gas, and they use detergents. In fact, if applying this to a UVC white box, there was a great study done by the team down in Sussex on the carbon footprint of washer disinfectors and steam sterilizers, and they are certainly very good solutions for moving from single use to reuse. But in some applications where you don't need that full that full capacity, a UVC white box can be very effective at a much lower carbon footprint. The energy consumption is much lower, so a fraction of what was there before. Obviously, that's subject to the capacity you need, so that this will be corrected depending on each use case. But you've got plenty of headroom, really. That's the point. Obviously, it's subject to all of the testing and efficacy testing, and we're running the trials on that now, which I'll come to. But a tremendous opportunity really to really save on the carbon footprint. And the other thing around the washer disinfectors is they are centralized units, so you have to get whatever it is you want to disinfect to them, get them reprocessed and get them back, and simply sometimes you just can't get it done in time. You know, so a lot of the times these are off site, so having them at point of use makes a huge difference as well. So this is the trial that we're just starting out. So this is a little bit of a sneak preview. I can't go into too much detail on it, but we're currently embarking on a trial with the NHS, and there's really 4 phases, or 2 phases that are again split down. So first of all, we have a laboratory phase. So we're going to run the accreditation on the new standard. It's only just recently that test labs have been available to do this. So we're one of the first companies to actually get accreditation to that standard. And again, it's 4 bacteria and 1 yeast, and the reduction is predicted to be achieved in 15 minutes. We actually got some results yesterday, which I'm just looking at, but actually we might even actually beat that. We might actually come down from that. So this is a very effective, fast cycle that we believe we can achieve. We don't stop there. Obviously, the standard is a standard, but what about recovery of this from actual devices? So we're going to actually do a second stage there, combining hypochlorous acid cleaning and UVC decontamination. And we're also going to introduce at that point an artificial saliva carrier on things like masks, so that we can understand how that can affect as well, because the real world is the real world and the standard test is the standard test. So we're combining both of those as prerequisites before we go to a site. Then we get to an NHS site, and we've already agreed this trial. This is going to happen in a point of use trial around about October onwards. Once we've got the certificate for the box, probably around a 6-week trial. And this is really all around the practicality of the process. But we're also going to do on-site swabbing of various devices as we go through that process. And then eventually, of course, we will be disseminating these results. We'll be disseminating to national stakeholders. We'll publish a case study, and hopefully we'll come back to one of these events to talk about it to the AHSN network. Just about point of use, we see this as being really practical in different parts of a hospital, not just centralised. So whether that's a theatre, a ward, device libraries are quite interesting because they contain a lot of the electronic devices that you can't put in a washing machine. So you can currently rub these down with disposable wipes, so actually make that reusable. Laboratories, clinics, and even mobile use, so an ambulance here, or even maybe if you're a kind of a community health worker in your car, these can be so small and compact. We could drive these off DC power from a vehicle. What items are in scope? So those of you that know about this would be familiar with the Spalding classification. We believe this categorizes the device classification and the level of sterilization you need depending on that. We're targeting the two lower levels, so non-critical and semi-critical. I think the full sterilization that you'd need centrally is still the domain of the water disinfectors and the steam sterilizers, but there are so many devices out there that really don't need that level of decontamination, but still need good levels of decontamination. A lot of log reduction that UV can help with. We need to trace this, of course. So just as I said earlier, we can RFID tag this. So we'll tag, this is an example of an anesthetic mask, is one of the devices we're looking at. We tag the mask, we tag the box, and we have an RFID scanner, and we have a database that can tell you the decontamination history of any of those devices. And what we really need here is just to get engaged, So I would say now, tell us what you need. What items do you feel could be reused that are not reused at the moment? Where can we help, eliminate disposed single-use waste? Where will it be really helpful to have it a point of use where the central sterile services just cannot cope, or it's just too impractical to do it? And have you got any items that are supply chain constrained that could actually be reprocessed? Because that's the other issue. We're seeing a lot of items where people can't get hold of enough disposable things at the moment, so they need to reprocess. And with that, I'll close. Thanks very much. I will put this in the chat if you like, but the email is on there, and please check out our website. Thank you.
Andy, thank you. That was a brilliant presentation, and congratulations on the BSI standard, because I know how difficult they are to get. We've got some brilliant questions in the chat. So Rich said, this looks really interesting. What is the current usage of UVC for decontamination versus other alternative methods, if you knew that, Andy?
Well, yeah, there are use. I mean, UVC is used to decontaminate them. I think the most common use is actually whole room decontamination, where you have these big UV lamps on wheels that you wheel into a room, and then you run it for a period of time, and it decontaminates the room. That's quite well established. The problem with that, of course, is that that's open UV, so you can't occupy the room at the time you use it. So this is a very different application for us now. So there are also UV cabinets to decontaminate things like scopes and ultrasound probes and things like that, but typically they get sent to central units, and also those UV cabinets use the traditional lamp technology, so they're much more energy hungry, and they're big capex purchases. These things can be really almost be OPEX type things, where you actually have them put around wards, and there's nothing else like that really that's being used at the moment. And so that's where we see the differentiation for this product as opposed compared to what's used before.
Yeah, That's
hopefully
fantastic.
the existing UV use gives credibility to its, you know, that it's as a method. We're not introducing a new method here. We're just trying to apply it in a much more modern way using the latest devices.
Yeah, no, that makes sense, Andy. Matt says, again, really interesting. What type of materials is this most effective on? I think you've answered this, but he's kind of asked, would it work on smaller textiles like masks?
It will work on. Will it work on masks? It will work on some, but with textiles where you've got a lot of rough surfaces, it's probably less effective. But we're looking at replacing the sort of the textile masks with reusable P3 masks. There are some really good new products coming out. For example, there's a transparent mask coming out for P3 use that's currently just going through certification itself. We've already modelled that in our box, and we're confident we can decontaminate that. So that would be a plastic material, but it will actually be a very much better thing. We're introducing some PPE ourselves, of course, and we'd be very happy. I haven't got time to go into that now, but we'd be very happy to discuss that as well. So it can be used on PPE, but you have to think more laterally about, you know, getting reusable materials in rather than just reprocessing what you're using now, I think.
Yeah, no, thanks, Andy. And then Jacqueline says, this looks great. I wonder about things like wheelchairs and chairs. Can you turn it around? Any softer furnishings that can be decontaminated?
Yeah. So again, it's important to get the interaction right between the UV box and the materials. There are materials that are easier to decontaminate than others. So it's about making sure that we have good interaction with the manufacturers of those materials. Wheelchairs, actually, if you saw the first page where I showed the 3 box sizes, the bigger box size, we call it the jumbo box. It's actually it's actually designed for wheelchairs. So that's already been modelled for wheelchairs. So that's something we could, you know, be happy to have another conversation about. Yeah. So there's plenty of opportunity, and we really need. I suppose what we do really need is all these ideas to come in, and then we can choose where it's most effective.
No, agreed, Andy. Thank you so much. I know you've got your email on the bottom of this slide, but would you be able to just pop it in the chat? And I would implore any NHS colleagues for the questions that he asked before about what do we need recycling, what do we need looking at. This should be a two-way conversation, so please put them down and feel free to reach out to him. But are there any more questions for Andy? No? Okay, I'm going to move on. Andy, thank you so much. Genuinely, that was brilliant. Thank you so much. And now I'm handing over to Matthew Price.
Hi.
Hi, Matthew.
Hey, how's it
over
going?
to you.
Yeah, and thank you for that, Andy. That was really interesting. I was asking a question on, you'll see why I was asking a question on reusable masks now. Let me just find my thing. Okay, hopefully you can see that, maybe?
Yes,
hopefully
perfect.
Perfect. So I'm not very good at PowerPoint presentations, so I've kind of just written this how I'm going to speak. So this is, hopefully it's, going to make sense. Essentially, MedicusCaps makes reusable scrub caps as its kind of main deal, and it's about showing that small things obviously add up to like a bigger impact, especially going from single-use disposables obviously up to reusables. So this is firstly my chat, obviously trying to cram everything, even just talking about reusable scrub caps into 10 minutes is quite a feat. So there will probably be more questions than answers, but I just want to first go over what disposable scrub caps kind of are at the moment. Generally, they're made of SMS fabric, which is essentially 3 layers of a kind of polyester type fabric, kind of bound together. And around 1 kilogram of SMS fabric is roughly equated, just to the production of it, to about 2.5 kilograms of CO2, or 12.5 grams for each cap, roughly. And the disposable range, so I will bring all of these together, so don't feel you have to memorize all of them, but the disposable range of hats is 2 to 5 pence. We kind of find at the kind of lower range, although some can go up to 20 plus pence depending on the kind of product codes that we've seen. We've surveyed people ourselves, and the average amount of hats used per day in theatres or a theatre setting is around 2.4. Most people using 1 a day, something like 40%, and then the next majority is 2, but some using upwards of 7. So it obviously depends on the role within the hospital. Typically, if we just take to build a kind of example of all of this coming together, if we say that there's 232 working days. If you're working kind of 5 days a week, then you would be going roughly through 464 of these hats. So obviously this is starting to add up, and the cost, depending on how much you're paying for these at procurement, obviously ranges. They're kind of obviously cheap and cheerful in a short-term window, but we'll soon see how that can kind of add up. And we've, to bring it back again, that's roughly 5.8 kilograms of CO2, and this is just for the manufacture of them. So if we scaled it to 10 theatres with 10 staff, you can quickly see, obviously the NHS England has around 3,200 kind of theatres at the moment. So any sort of operations that are going on those, depending on how many operations there are, obviously this just keeps scaling up and up. So it's a real issue. So we think we can do a bit better with reusable hats. So Medicus hats, 100% cotton, and so cotton on an average per kilo base, and we factored in, because we actually make the hats to order in Sheffield, we're roughly 133 grams of CO2, and we're easily lasting over 5 years. We actually started before it became more trendy in the pandemic, so we started in 2018. So we think already it's yeah, we've had really good traction so far, but it's feeling like a sweet spot now that all the kind of free PPE is running out from obviously that time. So to continue the example with our same person, we would recommend roughly 1 hat per working day. Obviously, you're not going to use 5 individual hats per day unless they all somehow got really contaminated. So the example is 5. So just to bring it back again, so we have the disposables at roughly 5.8 kilograms just to make them, and to make the same 5 hats for Medicus hats is roughly 665 grams. So obviously that's already like an 88% reduction just on like for like. And so by year 3, because obviously our hats last 5+ years, thanks to designs like the tie is being built into the hats. So to basically break the ties on a hat, you have to break the hat almost over your head. So we can see there that obviously because you still have the same 5, you're using them again and again. But obviously we're just talking here about the productions of the hats. And so we come on to obviously waste versus washing. And a lot of obviously the chats, it's especially as we move towards obviously net zero, is more about not necessarily finding one solution that, hopefully we're trying to find one solution that perfectly fits everything, but generally it comes down to trade-offs. So we think that there's a better trade-off in washing versus all of the waste that is going into the bin from disposables. So I just wanted to chat about that quickly. So the big question is basically, it's roughly half a penny to get rid of a disposable hat. This is based roughly on the ERIC data surveyed of hospitals for offensive waste. Obviously, there's caveats to that, such as nothing is ever perfectly segregated into its waste pathway. So that's one problem as well. But washing also comes down to a factor, because we have many different trusts that we're in that are using various different types of washing: centralized washing, external washing, industrial washing, even labs using autoclave, home washing. So the price per wash will kind of vary. So if we just put in the same numbers, just to keep it easy, for the NHS to get rid of 464 hats is roughly £1.85, and 5 reusables, it would depend on the washing machine. I've done here just a normal 7-kilo domestic washing machine that can go above 60 degrees to comply with NHS workwear, and that would be 48 washes, so 2 per working week. So yeah, that'd be cool. And obviously if you wash it, the £9.47 is basically if you only put 5 hats in a washing machine, which is obviously very ineffective use. So efficiency is kind of the key thing. Just to quickly demonstrate that, obviously if you're, again, similar to what I said before, it's costing, for a 7-kilogram washing machine, it's roughly costing you about 20 pence per wash. But obviously if you only put 1 hat in there, then that makes it really expensive. If you're putting 100 hats in there, and theoretically based on just the weights, you could fit about 200 hats in a washing machine. So the carbon footprint per year, so based on ERIC data of CO2 per ton, we get to roughly 120 kilograms of CO2 in terms of getting rid of the actual waste. And with 5 reusables, it's between 6.5 to 13 kilograms, which is based on the government kind of emissions generation for electricity. And I'll be happy to obviously share these slides because I realize I'm bombarding you with quite a bit of information, but just to bring it back again, essentially the totals there just show that you can already start saving significantly. This is just on year 1. There's a bit of more initial outlay because obviously you're purchasing reusable hats, which are obviously a bit more than 2 pence each. But then these hats lasting for 5+ years, even by year 3, you're already over break even, and you're still roughly in the scenario that we've kind of talked about so far on a 89.4% CO2 reduction. So taking it from 374-ish kilograms down to just 39, which we think is quite impressive. A couple of caveats with the example. Obviously, a lot is going to depend on individual trusts. So obviously, we do bespoke kind of implementations of reusable hats because there's a lot of different systems at play and a lot of different ways people want to use the hats. So we have lots of different options for that, which I'll talk more on in a minute. In terms of all the numbers that I've quoted for disposables, we've not accounted any emissions for actually transporting wherever you got the caps from. We're not factoring in the cost to actually produce the hats. Generally, these are produced with a machine that does things like surgical lasering, because it's a plastic hat. It's quite easy to do laser, or I think it's called sewing welding. And we're not factoring in any broken or waste from hats. Obviously, these come in boxes of 100. And so I would personally imagine it's quite easy to accidentally grab 2. But yeah, we're trying to give benefit of the doubt on that. And for us as well, obviously washing, for a reusable hat, washing is going to be the biggest kind of variant of how efficient you're going to be able to be with these. Like I say, we have people that are doing home washing, we have people that are doing industrial washing, so they have a variety in terms of the CO2 and the costs. So having lots of different ways to kind of implement it into systems that you're already dealing with, we kind of feel is the best way forward. But we wanted to take the reusable hat even further, because obviously I'm just talking about a like-for-like switch to help with sustainability and also comfort. So the main thing is we have better fitting hats, essentially. We have 6 main styles, including a hijab and a turban style, to obviously be more inclusive. We have extra small, which fits my toddler, all the way up to 2XL, which is just a bit bigger than me. We have mix and match on 87 kind of plain colors. So if you wanted to do different colors per department, all of that kind of can factor in, and even a different color top for the sides, for if you're doing separate washing. And a key thing for us was to do flat pricing on the 3 kind of main styles, most popular ones, which are the tie backs and the elastic backed ones. So then basically any size and any of those 3 main styles in any combination of colors is all the same price, and VAT exemption as well. So being able to offer VAT exemption at invoicing just means that budgets can go further. Generally, people will have a pool of money, but that is usually inclusive of VAT. So if you kind of factor that in, you can get about 16% more for your money. And names on rolls, names and rolls on hats. So one study in the US said name retention went up from 38% to 90%. So you remember 9 out of the 10 people that you were kind of working with in a surgery. Obviously, especially since COVID, even more masks, even more visors, even harder to see people. So that's obviously a key point in especially a dynamic environment. We have better patient interactions. Obviously, it's all well and good lying on a table and 12 people introducing themselves, all looking exactly the same with a mask on. But having names and roles, I think, makes it a bit easier to know who you're talking to. And even if they don't necessarily understand the role on the hat, it could even be a nice icebreaker. And we find that the hats with names and roles are generally better looked after. Obviously, not many people are going to think much about disposable hats. But something with your name and role on it, we find that people are taking more pride in obviously how they look, and yeah, for mixing and matching. And similar, coming back to that role identification, obviously within hospitals, there's classic stereotypes for like what gender does what role, or if someone is carrying, I don't know, anyone could be carrying a mop and you could just assume they're a cleaner, da 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 da. So we think that that is an interesting element as well in terms of names and roles. In terms of bespoke implementation, don't worry, I'm nearly closing out all of the different options, but just to touch on them quickly, RFID tracking, which we've already heard about today, is really useful in terms of tracking where things are. If you use them with hats, you can see even where people have roughly been in the hospital. Different colored tops makes it really easy for external laundry. It makes it easy for team recognition and sorting and coming out. We also make the hats to order, so I don't just have a warehouse just of all the different sizes and styles. We literally make bespoke to whatever your needs are, which obviously significantly reduces waste as well. And we can even offer custom fabrics, and we've had these tested up to industrial laundry standards, so they can withstand even, I think their drying is something like 180 degrees, which is pretty hot. So they did that as well. So I'll leave a couple of key takeaways there, but one is kind of disposables themselves in terms of the SMS ones are not as robust as cotton, such as they are actually better at breeding airborne contamination. They also shed a bit more than cotton. You can easily see that obviously if you throw away nearly 10 times or 100 times more hats than a reusable, then it's going to add up in CO2. And one interesting one was that we found more staff were actually more interested in finding ways to be green within the hospital. Obviously, a lot of initiatives are around maybe staff travel. Otherwise, there's bigger infrastructure projects that are taking a long time. And so having people in theatres know that every time they're putting their hat on, they're effectively saving 12.5 grams of CO2, I think is quite nice. And also that no one size fits all. So basically being able to implement it with you however you want obviously makes it super easy for people to adopt it how they want and find which elements of it they kind of get the most use out of. And so with that, that's the kind of rough email. We're quite a small team, so it's quite useful to have a group email. I don't know if there's any questions. I know I rattled through quite a lot, but essentially disposables, lots of waste, needs changes to reusables, a better solution with a load more additions and customized and bespoke to how you want to implement it. So I don't know if there's any questions to that, but I will happily forward on this as well, because that I can understand that was quite intense.
No, Matthew, that was brilliant. Just from my perspective, I love that you haven't just done like for like and you've got different colours and sizes. I love the names and roles as well, and kind of the personal element. In terms of sustainability, 80%, 88, I think it was, % reduction in carbon is so impressive. It's huge. I love that you've brought to light the waste versus washing discussion, because I think that's going to become really, really big. And you do often find in sustainability there are bigger initial costs, but then you see the financial and carbon savings later. I haven't seen any questions in the chat. Is there anyone that wants to jump in with a question now? Or Matthew, you might have just covered it so perfectly that nobody has anything to ask.
It's the benefit of only doing one product, I guess, with a million customization points. But essentially, one thing I will add as well is that our next kind of stepping stone for this, to actually be able to take it even further, is we're currently trialing hemp. And hemp as an actual fabric is not only antimicrobial, but it's carbon negative when it comes out of the ground. So essentially the carbon it takes to make the plant, by the time you've processed it into a fabric, it's still carbon negative overall. So we're quite excited to be able to then implement these into hats. We're obviously currently testing things like washing and being able to reliably source these, because it's a fairly new kind of frontier in that respect. But then we could even see the first kind of carbon negative PPE, which I think would be even more exciting.
It would. No, Matthew, that is brilliant. Thank you so much. Would you just do me a massive favor and just pop that email address in the chat so people have access to it now? But Matthew, thank you so much. Thanks so much. And now I'm handing over to Griff, who I saw come on the screen before. Hi, Griff.
Hi, Amelia. Hi, everyone. So my name's Griff. I'm one of the co-founders of Zedible, and I'll jump right into the slide presentation. So I'll just share my screen and we can jump in. So share my screen. And can you all see that?
Yeah, perfect, Griff.
Perfect. Okay, well, like I say, I'm one of the co-founders of Zedible, and it's all around making CO2 a KPI in the context of food. So food really matters to the NHS, and Zedible can sort of help navigate that journey towards net zero. So before we dive into food in the NHS, let's just have a look at why food matters for net zero. Now, it really does matter, and any sort of credible attempt when you're looking at, you know, country level, organization level, around net zero needs to look at food, because food accounts for 26% of global emissions. Now that percentage figure is then broken down to a range of different areas. So land use for livestock, land use for human food, crops, livestock, retail, transport, packaging. But taken as a whole, it accounts for over 25% of carbon emissions. Now, an interesting point, and one that is quite often misunderstood, is that transport and packaging are not the key drivers of CO2 in the context of food. So it's not just about saying we're going to have a local sourcing policy or we're going to remove plastic from our packaging. Effectively, the carbon is on the plate or in the serving dish that you serve it in the NHS. The carbon is the food. And so understanding how food impacts your carbon footprint is absolutely key for navigating towards net zero. So that's why food matters for the world. Why does it matter for the NHS? Well, from an NHS perspective, you serve lots and lots of food. The latest statistics that we could find was 199 million meals per year for patients, staff, and visitors. Now, taking some statistics around the average carbon footprint per meal, we took this from the WWF, the latest figures for the UK, we equate that to around 1.48 kilos of carbon per meal. Okay, so some simple maths mean that we can extrapolate that the NHS's carbon footprint in the context of food equates to 300,000 tonnes of carbon per year. That is a lot of carbon. Bringing it perhaps into context with other things that the NHS does, it represents 9.5 million call-outs, ambulance call-outs, or 68% of the total carbon driven through ambulance call-outs for the NHS. So there's an awful lot to go after when we're talking about food. So let's say hello to Zedible. It's all about understanding at an ingredient level what's driving carbon in an organization. So it's a cloud-based software platform which takes purchasing level data and massively improves, sometimes introduces in the first instance, the measurement and then the actionable insight around carbon reduction. Now, I think it would be useful just to take a beat and look at what else is out there and why Zedible's different. So the other two approaches around carbon measurement is carbon accounting, and often when we look at food is carbon labeling. Now, carbon accounting works reasonably well when we're talking about scopes 1 and scopes 2, because it understands carbon in a spend basis. However, when you're looking at supply side and scope 3, spend isn't the best lens to understand what's driving your carbon. It's more about what you're buying and in what quantities you're buying it, as opposed to how much you're spending on food. So that's point 1. Point 2 is around carbon labeling, and so far evidence shows that the impact is really, really mixed in terms of allowing people to decide to go for lower carbon options. So our approach is for organisations to first understand the materiality of what's driving carbon in their organisation. And then once you understand that, you can make changes to the ingredients or the products that you buy to reduce your carbon footprint. So if we have a look at what it looks like at a high level, we do all the heavy lifting, processing monthly aggregate purchasing data across your supply chain, again, within the context of food. And we provide some high level dashboards which show you carbon and crucially carbon intensity. Now, obviously carbon will have a relationship with the number of meals you serve. So the more meals you serve, the higher your carbon footprint. However, through menu engineering and supply chain engineering, you can actually bring that carbon intensity down, even with increasing meals served. So this is the first dashboard that you can see. And what we've done here is we've established a carbon benchmark based on the previous year's data. And then through ingredient substitutions, we've actually been able to significantly reduce the carbon intensity of that operation. In this case, by over 14% in just 7 months. Okay, once you've understood that, you can then start talking about carbon averted. So it makes it really simple to understand the impact that you're having through supply chain changes. Deep diving into ingredients and supply is obviously key. The previous slide showed you the outcomes of this bit here. So Zedible really focuses on the things that matters. Materiality matters. So here we can see on the sort of bottom left side, the ingredients that are driving carbon in an organization. And on the bottom right hand side, we can see the suppliers that are driving carbon in the organization. So it makes it really clear for organizations to understand what's driving carbon at an ingredient level and a supplier level, and then you can start to have conversations with your suppliers about how they can reduce that carbon figure. So it's super actionable. The other thing which I've yet to touch on is the commercial impact of changes. It's all well and good to say if we were to swap dairy milk for oat milk, it would have a massive impact on carbon. However, carbon doesn't sit in isolation from the commercial impact. Everyone's got budgets to hit. And so for changes to be enacted, it's absolutely key that ingredient substitutions or supplier substitutions are understood both with a carbon lens, but also a commercial or a financial lens. And that's what the sandbox does. So if I just skip forward here, you can see that if we were to change full fat milk for semi-skimmed milk, this would be the impact on carbon and cost. And that's a key bit of information that needs to be had before any changes are made. So hopefully you get a good idea of the platform. And my business partner now, Ed's just going to give us a quick fly through of the platform so you can see it in action.
Welcome to Zedible, the carbon software platform focused on the CO2 originating from food and drink purchases. We pull in month-by-month purchasing data and analyse that to give the CO2 from that, which is the category 1 scope 3 emissions. We also pull in a revenue figure or revenue equivalent. Combining those gives you the CO2 intensity. This is actually what's happening as a result of purchasing decisions and improvements made. We can start to see how benchmarks are established after a full year of data, and then how progress can be made and ultimately CO2 averted from those purchasing decisions. It's a very detailed platform where we can see the CO2 by category, and then you can start to see it by supplier, and really importantly, you can see the materiality by individual products. Now, this is where you can start to really understand what is worth focusing time on in terms of carbon reduction. A feature of the platform that we're really excited to present is the sandbox. This is where you can simulate the outcome from a carbon and a commercial perspective of potential changes to individual products or even supplier. So we can see here, this is an example of alternative butter substituted with dairy butter. So it's really insightful. It helps to give informed decision making, and hopefully you found this quick fly through an interesting insight into what Zedible can do.
Great. So that gives you a flavour of how it works and how it flows. Here are some case studies, admittedly not of NHS trusts, but of real life businesses and organisations where food is a significant driver of carbon in their organisation. So here we can see with a handful of ingredient substitutions, the impact both in terms of cost and carbon that changes can make. They're significant. I mean, a high of 14.9% with a cost saving of £4,500, that equated to about 4.5% on their monthly spend. So we're talking about big pound savings and big carbon savings, which can all be visualized through the platform. So let's bring it back to the NHS and the art of the possible. Like we started off by saying, you serve a lot of food. A 60% reduction in CO2 is generally believed to sort of represent the art of the possible in the context of food. So if we take that and work that through the food carbon footprint in the NHS, this is what we get to. So 1%, 5%, 10%, and so on. What do those figures actually equate to? Big savings. So a 1% saving in footprint on food would equate to 2,945 tonnes or 94,000 ambulance pickups. And if we take that all the way to 60%, you're talking about 176,000 tonnes or 5.5 million ambulance services. So Zedible, we can be the map and compass of for the NHS to sort of help that navigation towards net zero in the context of the food you serve to your patients and colleagues. So more than happy to take any questions from anyone, and thanks ever so much for your time.
Thank you, Griff. That was brilliant. Do you know what? There actually isn't many food innovations, and to just learn that there's 199 million meals produced a year, that's overwhelming. So that was just brilliant. And I love that your platform looks at cost as well. We often talk about in the Greener NHS team care, cost and carbon, because trusts and integrated care boards do have a budget. So it's brilliant that you're kind of thinking about that in the substitution. So that was fascinating for me. Does anybody have any questions? I'm going to open it up. There's nothing in the chat, but feel free now to jump in if anyone has anything. No, Griff, it's obviously because you covered it so well.
Thanks, Amelia. Just a sort of small technical point. The data we use to understand the footprint can be taken from any purchase to pay system. So perhaps the different trusts and hospitals have different purchasing systems.
Yeah.
Our platform can actually use natural language processing to understand data from any purchasing system. So it's system agnostic, and it gets right to the cause of what's driving carbon within the context of food.
Oh, Griff, thank you so much. Will you do me a favour and will you pop your email address in the chat as well?
Of course I will, yeah.
Thank you so much. And thanks, Griff, for coming today.
Thank you.
Nelson, I can see you on the screen already. Very organised. So I'll hand over to you.
Hi, Amelia.
Hi.
Good. And good afternoon to everyone. Very pleased to join you and to introduce HOCOL. It's a game-changing solution, we believe, to a number of issues facing the NHS. So I'll just get my screen shared, if I may. So I hope this works. Is that live?
Perfect. It's on the screen.
You're seeing that?
Yes.
That's great. Good. So,
Well, I've sent that out to JJ. I mean, we could find that we get quite an uplift.
I think we've got some
They've got on
a little
mute
bit
now.
of competition there. Very good.
Over to you.
So, Our mission at HOCOL, and I'm going to give you an overview of our of what HOCOL is about, and I'm sure there may well be questions as we get to the end, and hopefully there'll be some time for that. So our mission at HOCOL has evolved over the last 18 months as we've become more acquainted with the challenges that are being faced by the NHS post-pandemic, with the rise in infections and antibiotic resistance and so forth, and lower immunity. And we've defined our mission as the following: as to eliminate avoidable hospital-acquired infections safely, naturally, and effectively. And so what is HOCOL? Well, HOCOL is the brand name of hypochlorous. And it's a groundbreaking development in the world of disinfection because it consists of just two components: water and salt. And so it doesn't get much more natural than that. And it goes through a process of electrolysis. As an overview, it's a solution that has exceptional killing capacity with up to an 8-log reduction, and it kills all known pathogens on contact. And it has a remarkable safety profile as it contains no hazardous chemicals. And the way HOCOL is produced goes through this process of electrolysis through quite a sophisticated membrane, which is split. And on the anode side, we produce hypochlorous, and on the cathode, we produce sodium hydroxide. Hypochlorous being probably the most powerful natural disinfectant on the planet, and sodium hydroxide is an extremely effective cleaning and degreasing agent. And these two solutions can either be used separately or combined. And when they're combined, they produce an incredibly powerful disinfectant, which both cleans and disinfects with up to an 8-log reduction. So just to explain, why is HOCOL so much more effective than currently used chlorine-based products? And it requires just a simple understanding of the chemistry behind here. All pathogens are negatively charged, and when we try and kill them with hypochlorite, which is i.e. bleach is all in the pH range of between 8 and 15, and that is also negatively charged. So for us to deal with these pathogens when we're working with hypochlorite, we have to go to very high concentrations to be able to penetrate the cell walls. Whereas with hypochlorous, it's a hypochlorous, sorry, it is neutrally charged. It sits in the mid-range pH, and it's neutrally charged at 7.2. And with the neutrally charged ions will then penetrate the cell walls very fast. And once inside the cell, the hypochlorous denatures the proteins, leading to cellular death. And this is a very fast-acting process, which just takes seconds. So this eliminates the extended dwell times that often go against the effectiveness of a lot of disinfectants. So onto sustainability, and this is very interesting because we can claim that it's 100% sustainable, and it's quite an incredible story because the core products are just water and salt. And so we actually looked at the carbon footprint, which is a subject that I certainly don't have a huge amount of understanding. So we brought in a firm of consultants, Danish research company called Force Technology, and which demonstrated a 96% carbon reduction. And this was actually against using a stabilized HOCOL product in a bottle being delivered every month into a facility versus on-site generation, which is really turns this into a game changer. So even when producing HOCOL with all its many environmental credentials and benefits, the difference between producing it on site and having it delivered in is very, very significant. And then when you consider this against the typical synthetic chemicals, it'd be many 100 times more it's carbon usage. We don't have the numbers, so we can only compare it with against our own products, but it's very significant. And so, as you can see on the screen here, it takes 8 years when you use on-site generation to produce the same amount of carbon as you would produce in 1 month if we were to deliver it in a bottle. So, just talking about efficacy, we have done a very extensive testing against a very wide range of pathogens, and I'm sure the list on the screen will be well recognized, but there's the ones that are causing a lot of trouble, such as C. diff, norovirus, and so forth, are the cause of an awful lot of cost to the NHS and also misery for the patients. But it involves a lot of bed blocking, the need to decontaminate wards and so forth. And if we can deal with that in a much faster and more effective way, that without risk, then we believe that we can make a dramatic impact on the number of hospital-acquired infections, which are proving to be a significant challenge, I think, across all trusts. So let's talk about on-site generation. When we generate on site, you achieve the optimal benefits of what is already a very highly sustainable product. And by generating in situ, you have it available 24/7. You're producing it to a known standard and specification, which provides significantly improved outcomes. So there's no risk of degradation or changing of the composition of it. And what we're finding is you will achieve improved hygiene standards, improved safety, reduced environmental impact, reduced costs. And then there's the ones that are more difficult to quantify, such as the reduced requirement for PPE. There's no requirement for COSH. It's a non-hazardous product, so there's no COSH requirements. There's virtually nothing in the way of waste disposal. Major reduction in single-use plastics, and of course the carbon footprint reduction. During the process of our journey with the NHS, having got a remarkable solution that can solve a lot of problems, we then challenged as to how do you get it from point of generation to point of use. And we've been doing a lot of work with different trusts to actually establish how you can get it from A to B and actually make it work. So we've produced a range of generators, from very large, where you might just have one single source of supply and then transport it to the various locations around the estate, or alternatively, you might have multiple points of generation, which often is more convenient. And then there's means of getting it from those points onto the ward, and then working with the domestics to where it can just be put straight into their trolleys. And it's also opened up a whole range of opportunities that don't currently exist when you're using toxic and hazardous chemicals, because this is much more friendly. You can mist, you can spray, and without the same concerns you would have if you were working with toxic chemicals. So a brief summary, if you like, of as to its safety and efficacy profile. We've got it's non-toxic, it's non-hazardous, it's hypoallergenic. There's no requirement for COSH. It's ideal for use, around vulnerable people, and there's no requirement for PPE. Of course, there doesn't mean you wouldn't use it in certain circumstances, but there's no actual requirement. It will disinfect for hard and soft surfaces, and it's extremely effective at odor control. It will break down the cause of the source of the odors. So if we're not talking of an air freshener, we're actually dealing with the root cause of the problems here. And then, of course, it's safe to dispose of. So it's just some of the benefits you can experience. And then from an environmental aspect, once it's been used, it just simply decomposes almost immediately back to its former state into just water and salt, which leaves no residues. It eliminates the need for transportation, and of course, packaging, waste, storage, all of those things are no longer required. It's safe for aquatic life. In fact, it's actually used. One of the areas it's used is for water treatment. Extremely energy efficient, and releases no VOCs. It's fully biodegradable, and you can control the water usage. So there's no overuse of water at all. So that sort of brings us to where is it actually being used, and our journey with the NHS is relatively recent, and we've been working hard to bring this to the attention and to get trust to trial this and actually prove the benefits. And it's used in many countries already, and we're very keen for this to be taken up in the UK. And of course, all things healthcare are included in this. Nursing homes. It's already used extensively in the dental world as a mouthwash and for root canal treatments and so forth. It's used extensively in the animal world of veterinary, equine, and avian. Our largest market currently in the UK is in the cruise ship industry, which has certain similarities and requirements to healthcare. And then it's food safe, so for the washing down of machinery and equipment in the food sector, and restaurants and hospitality, etc. So there's a broad range of use which can be used everywhere. And I think the circling back to our reason for existence is that we believe that when we treat the root cause of so many of these problems in terms of effective and safe disinfection, we can make a very big difference to the number of hospital-acquired infections, which of course have all that knock-on costs in terms of taking up beds. The cost of actually treating HAIs is very high, and of course a miserable experience for the patients who contract them. So that wraps up our presentation. I'll be very happy to take some questions and be very glad to share slides. And there's also a considerable amount of studies and so forth available, as I realise we've touched on a lot of subjects and very quickly here.
Nelson, thank you so much. What an impressive presentation. I mean, I've wrote so much down. Kills the 9 pathogens, no hazardous waste, no need for PPE, reduction in single-use plastics, reduction in carbon footprint. It's really, really impressive to see. There aren't any questions in the chat. Would anybody like to come in and ask any questions? Or Nelson, I'm sure you'd be happy to put your email address in the chat as well. So if anybody wanted to reach out to you, but you might have covered it all. That was fantastic.
I'll certainly do that.
Thank you very much. I think we do have a question. Rodney, please jump in.
Yeah, no, it's more a quick comment, and just
Please
thank you for your presentation. I'm Deputy Director of Nursing for Innovation and Sustainability in NHS England, and really interested in your commentary, particularly around infection prevention control. So infection prevention control, if you like, is a critical source of assurance and reassurance to our staff, hence the reason why many of them use single-use items and single-use products. and we are seeking to reverse that. So we are about to embark on a piece of work really just looking at the relationship between the principles and disciplines of infection prevention control and the principles and disciplines of effective sustainability. Really interested in your presentation today, and with the organizers' permission, I'd really like to be able to use and share your presentation more broadly with my colleagues, because I think it offers a basis in which to have that wider and deeper conversation about how do we create the behavioural as well as structural solutions to sustainable healthcare. So thank you so much, sir.
Appreciate that, Rodney, and thank you very much. And I didn't mention, but I should have done, is that to go along with the introduction of HOCOL, there is also, we're devising an entire training program, which we're working with a number of healthcare professionals on to be able to introduce the necessary knowledge, it's just about managing change, so that this is used correctly and effectively to get the maximum benefit from everything it offers.
Fantastic, Rodney. Thank you so much for coming in there. Everybody who's attending today will receive all the slides, but I would absolutely recommend Rodney and Nelson probably connecting separately. And then Nelson, if you're happy to share the slides, I mean, that's completely up to you.
Delighted, no problem at all. Anybody would like it, just drop me a note. I've just put my details in the chat.
Oh, thank you so much. And I don't think there's any more questions, Nelson. So the biggest thank you for presenting and joining us today. That was fantastic.
Thank you very much.
And I just want to say a massive thank you to James, to Rob, to Andy, to Matthew, to Griff, and to Nelson for presenting today. I mean, I've worked in the NHS now, well, in the network for 1.5 years, but I felt like I've learned so much. We've got 10 minutes before the final roundtable session. Get a cup of tea, get a coffee, get a crumpet, and then hopefully I can see some of you there for the final roundup. But yeah, thank you so much for joining, and I hope everyone's had a great day. If anyone wants to speak to me or ask me any questions, I'll pop my email in the chat as well. But thank you so much, and I'll see you in a bit.